Hai semua, hari ini kita akan discuss bagaimana nak menulis reaction mechanism for hydrohalogenation of alkenes dan juga reaction with acidified water of alkenes. Okay, kita mulakan dengan hydrohalogenation. Okay, langkah pertama untuk show the mechanism is to show the formation of carboxyl ion. So since in propene, we have a presence of carbon-carbon double bond, and we know that the carbon-carbon double bond is the rich electron region, so this carbon-carbon double bond is known as nucleophilic site. So the nucleophilic site is very reactive toward electrophilic attack. So in this reaction, we are using the HBr to react with the propene. Thus, HBr will provide the electrophile that will attack by the carbon-carbon double bond in the propene. Then it will break the bond between the hydrogen atom and the bromine atom. From this reaction, it will produce the carbocation and the Br-. But remember, the addition of the hydrogen atom in the propene must follow the Markovnikov rules, which is the hydrogen atom is added to the carbon-carbon double bond with a greater number of hydrogen and produce the carbocation. So from this step, we have produced the secondary carbocation. Okey, langkah kedua adalah menunjukkan bagaimana nucleophile menyerang carbocation yang terhasil daripada langkah yang pertama. So from the step 1, we have produced the secondary carbocation. So this carbocation is very reactive towards nucleophilic attack. So from the first step reaction, we have produced the Br-, which is the nucleophile. So this reaction is very reactive, which is the Br- are easily attack the C+. Then it will form a bonding between the carbon and the bromine atom. Now we have produced the secondary haloalkenes. Now, what if the propene react with HBr but in the presence of peroxide? So when we have the propene react with HBr in the presence of peroxide such as H2O2, so it will produce the product of haloalkenes, but the addition of the hydrogen atom to the carbon-carbon double bond will follow the anti-Markovnikov rules, which is the hydrogen atom will be added to the carbon double bond with fewer number of hydrogen atom, and the bromine atom will be added to the carbon double bond with a greater number of hydrogen atom. So, how to write the reaction mechanism for this reaction? Langkah pertama untuk menulis mechanism adalah menghasilan carbocation. So first, the propene with carbon-carbon double bond will attack the hydrogen atom from the HBr. And it breaks the bond between the hydrogen atom and the bromine atom. So from this reaction, it produces a product that follows the anti-Markovnikov, which is the addition of the hydrogen atom will be added to the carbon double bond with less number of hydrogen. And then it will produce the carbocation and also the Br minus ion. So from this step of reaction, we can see that it produces a primary carbocation. So the primary carbocation is the least reactive. Thus, we need to consider whether we have to do the rearrangement to get a more stable carbocation. So since from the structure of the propenes, we can see that there is possible to rearrange the hydrogen atom to get a more stable carbocation. So we have to do or to show the additional step for rearrangement. Okay, langkah seterusnya adalah to show the rearrangements toward the carbocation. Why we do the rearrangement? It is to get a more stable carbocation. So daripada langkah pertama, we have produced the primary carbocation. Okay, this product is according to the anti-Markovnikov rules. So from the structure, we can see that we can change the position of the hydrogen atom to the carbocation so we can get a more stable carbocation. So this process is called 1,2 hydride shift. Okay, jadi pada langkah 1,2 hydride shift ini, kita akan shift the position of the hydrogen atom to the carbocation. So that will produce the change of position of the hydrogen atom to the primary carbon to become CH3. And the secondary carbon produce the carbocation. So now we have produced the secondary carbocation. So comparing this reactivity or the stability of the carbocation that we produce from step 1, which is we have a primary carbocation, comparing with a secondary of carbocation that we produce from the second step. So we know that the secondary carbocation is more stable than the primary carbocation. So the next step, we will use a more stable carbocation to show the nucleophilic attack to the carbocation. The last step is to show the nucleophilic attack. So since we have produced a more stable carbocation, which is the secondary carbocation, so it is easily attacked by the nucleophile of Br minus. So Br minus will attack the C plus and form a bond with the carbon atom to get a haloalkenes. So now we have a secondary haloalkenes. So this is the major product for this reaction. Alright, so now let's try for another examples to write the reaction mechanism for hydrohalogenation. So let's say we have an example of 2-methyl 2-butene. So if 2-methyl-2-butene react with so the first step is the carbon-carbon double bond will attack the H plus from the HBr and breaks the bond between the hydrogen and the bromine atom. So it will produce the carbocation. But remember that since in this reaction we have no presence of peroxide, so it will follow the Markovnikov rules. Thus, the addition of the hydrogen atom will be added to the carbon atom, carbon-carbon double bond atom with a greater number of hydrogen atom. Then it will produce the carbocation and the Br minus. So from this reaction, we have produced the tertiary carbocation. So we know that tertiary carbocation is the most stable of carbocation. So then we can proceed to the next step, which is the carbocation is attacked by the nucleophile. So the tertiary carbocation that has been formed from the first step reaction is easily attacked by the nucleophile, which is the only nucleophile that present in this reaction is Br minus. So Br minus attack the C plus and form the haloalkenes. So this product form is called a major product, which is it has been determined by following the Markovnikov rules. So if we have the same example but the reaction with HBr in the presence of peroxide, it will follow the anti-Markovnikov. Alright, so what if we have 2-methyl-2-butene react with HBr in the presence of peroxide? So let's start with the first step, which is the 2-methyl-2-butene react with HBr in the presence of peroxide such as CH3OOCH3. Okay, from the first step, we know that the carbon-carbon double bond, which is the nucleophilic site, will attack the positive hydrogen from the HBr and breaks the bond between the hydrogen atom and the bromine atom. So from this reaction, it will produce the carbocation. But remember, since in this reaction we have a presence of peroxide, so the addition of the hydrogen atom must follow the anti-Markovnikov. So the hydrogen atom will be added to the carbon double bond with less number of hydrogen atom and produce the carbocation as well as Br minus ion. So the next step is to consider whether the carbocation is possible to produce a more stable carbocation. From the first step, we have produced the secondary carbocation. So if we can see from the structure, so it is possible if we can rearrange the position of the hydrogen atom to the carbocation, so we can produce a more stable carbocation, which is the tertiary carbocation. So we show the next step for the rearrangement that involve the changing the position of the hydrogen atom to the carbocation. Okay, so this hydrogen is rearranged to the carbocation, and this process is called 1,2 hydride shift, which is shifting the position of the hydrogen. So from this reaction, we will produce the new carbocation, which is the CH plus has gained one hydrogen from the rearrangement and the neighboring carbon left as carbocation. So now from this step, we have produced the tertiary carbocation. So this tertiary carbocation is more stable than the secondary carbocation. So we will use this carbocation for the next step for a nucleophilic attack. So this tertiary carbocation is then attacked by the nucleophile, which is the only nucleophile that we have in this reaction is the Br-. So Br- is easily attack this carbocation and produce the major product.